Hello and welcome. I'm Bill Wake. We're going to continue today on our music Similarity app. We've done a bit of work yesterday on notes and parsing them with accidentals and octaves, which is a good start. I wrote a good little tweet thread about more stuff that could go on for notes, but the one I want to focus on today, well, we got a little work to do first, but I want to focus on the notion of keys. So if you have the key of G, you have 1 sharp, F sharp by default. And our notes should know about that, I think. It's hard to know for sure, but there are cases where an F sharp caused by the key signature is kind of different than one that was just marked as an F sharp. So we'll look at that. Okay. I tried to do a little work afterwards yesterday to straighten out this warning from my update, but I could not quite get that worked out. So we're back where we were. We're going to live with that today. Let me run the tests. Where we left off was we had defined a note parser that knows about the accidentals. These are the flats, the sharps, and the natural here. So we have an accidental parser that looks for a flat, looks for or an equal or a sharp. And then we have a parser that knows how to get the notes and knows which octave goes with it. And then finally, we know how to match the commas or quotes that indicate octaves up or down. And you can mix and match. You can go comma, comma, quote, quote, and end up with no different than you had. Okay. We defined a note parser is the accents followed by the note letter followed by an octave modifier. What we haven't done is taken the product, the results of those things. So the accidental one produces an accidental or a nil. It's optional. Let's see, does our accidental parser reflect that? Not really. Okay, we're going to have to make that optional. Optional accidental parser followed by a note parser followed by the octave modifier, which is also optional. Well, we have a star on that one. That's okay. Good. Okay. So optional accidental followed by an actual note name followed by an octave modifier. And what that produces is this produces an optional accidental. This produces a letter, comma, octave number, and this produces some octave modifiers as an array of characters. Okay, and we'll want a function that converts all that. Basically, it's applying these business rules. Okay, this drop first stuff, that's the matching. The accidental equals natural or whatever. We've done that part of the rule. But we haven't done the put the whole thing together part. Okay, so uppercase 4 or 5. Yeah, we embedded that part. Here's the octave plus or minus 1. We have to do that work. And creating the actual note, we have to do that work. Okay. Well, I don't know. My experience is it's not too hard to create those little function routines and have them match up, and it all just kind of works. Let's do that. Okay. And I think our note name. Okay, our parser. Let's do $0 uppercased. Okay. And this one is already uppercase. So the letter we want to get out the normalized letter A through G like that with the right octave. Okay. And what's the problem? Character string. Okay. It may be easier to do that later. Doesn't like it here. Okay. The problem is these two have to produce the same thing. Well, I can do that in both of them. Okay, now they're the same. Okay, so it's okay. The or bar says things must be the same. All right, and then we're going to put it through a function. Well, the question is, are there potential errors, or is this just, given these things, we know how to build the thing? I think it's the latter. Yeah, I would say the latter is true. So we need a function that takes the stuff. I'll call it build note, and it's going to take, well, let's call it accidental pair octaves. Accidental note octaves. Okay, the type of that thing is, well, it's a little complicated. So the type of this expression is an accidental. The type of this one's an accidental. The type of this one is an accidental. So all three alternatives produce an accidental. So that one's pretty straightforward. The uppercase now produces a string, one-letter string. Maybe I need to find out if you can uppercase a character directly. That's probably a good question. And converts all lowercase in a string. All right, but we really want the character, so let's try again. Swift character. Yeah, you'd think I could just get the Apple ones right on the top of the list. Well, can I get close? Can I get string? Swift programming language. Okay, maybe that'll be close enough. Oh, no. Wow. Int. I really have to bookmark this thing. All right, what's a class? Range. Swift UI. Trying to find a name that will be. No, this is not good. Okay. Swift string. Let's just try it generally. Yeah, I really want more documentation. I don't know how Apple doesn't come up high on the list here. Maybe we'll get a link. Okay. I'm gonna bookmark this. I know there's a way to do it in the thing. Maybe I should have been doing that. Okay, let's find upper. Is uppercase. Uppercase produces a string. Ugh. Case conversion can result in multiple characters. Yes, that's true. Okay. Yeah. All right. It's a string. Okay. So the sequence, the ampersand, when it's got both sides like this, it says make a pair out of these two and then make a pair of that with this. All right. This is optional accidental. Where's my, there we go. So it's accidental question mark along with the string that our uppercase produced, and then that pair is it's with basically that star thing must produce an array of character. Okay, so if you had that stuff, can you produce a note? Let's hope. Okay, so to do that, we have to find the note name, which we have uppercased already, the accidental, and the octave. Well, oh, that's a pair in there. I misstated the type. Okay, this note, it's really note plus octave bass. Bass octave. I don't know. I'm kind of breaking the style guide here by doing this, maybe. But I think gonna have to. Okay, and the type is not string. It's really string plus an int. Okay, so this is kind of the worst part of this process, that we build up this horrible type, and then we have to write this function that's very specific to our parser, because nobody else would produce this type for us, most likely. All right, but once we have that, we can peel it apart and let accidental note bass octave equal let's see, accidental note bass octave with octaves equals our argument. Okay, that peels apart the octaves, and then let accidental note bass octave. Well, can I try? I'll try it the whole way. I'll finish this thought. Equal accidental note bass octave. Okay, I might be able to do the breakup in one move though. Let's try that. So this is accidental note bass octave. Okay, can I do that? Okay. Oh, it's happy. Okay, good. Accidental, and this is note and bass octave. Equals all that. Okay, I think we are good. Accidental, note bass octave, and octave modifiers. Modifiers. Okay. Whew. All right. And I don't know, I'm not sure that name really tells you anything, but okay. So given this, the accidental, we can just pass it into note. All right, so let's just return note with note name and accidental and octave. All right, we haven't defined octave yet. All right. Okay. Now the octave is basically take the base octave and then do this plus or minus one thing. So if it's a comma, it's -1. If it's a quote, it's +1. Okay. I don't know if we have a count. Well, so let octave equal base octave plus net octaves. Okay, and then net octaves, I've got to calculate that. So it's really well, I think I can do a reduce. Okay, let octave equal octaves. Is that what I call octave modifiers? Dot reduce. The starting value is base octave. And then previous, next, in, and then we want to do previous plus, and if the modifier is, I guess this is modifier. Words give me trouble today. If it's quote, then it's a +1, else it's a -1. Okay, we know it's only going to be commas and quotes because we parsed it that way. Okay, so if it's a comma, it goes down 1. If it's a quote, it goes up 1. All right, octave is not there. Accidental. Okay, yeah, accidental. If it's not specified, then it's .in key. Okay. There may be a way to make the grammar do that for us, but it's okay. Okay, so we have to peel apart this horrendous thing we pass in. We accumulate base octave plus +1s or -1s and use that. Okay, so given all that, which I realize is a thing, and we feed that in to that name function, build note. Okay, so the actual parser isn't bad. It's the accidentals followed by the note letter followed by the octave modifier, and take that stuff and build a note from it. And the result of that, it's a mess. It's long, but at the end you can see the result is note. Okay, so a lot of stuff goes into it, but the end result is a note. Okay, now we haven't done anything with it. Let's make sure tests are still okay. We're not calling it, so there's no conceptual problem. Okay, now note, let's see what we got. Notes is a note string. Well, that's actually not quite good enough, is it? Okay, let's see if we can. Yeah, where we are today. Okay, our parser. If you pass a string of notes to our parser, it only knows how to break up individual notes, which corresponds to letters. So let's go back to tests. take a look at Parsons code tests. Every one of these passes in a string of letters with no modifiers. Okay, we don't support them in notes yet. All right, so I'm kind of gonna do this take it slow thing. I've got a single string in. Sorry, yeah, this is my main note function. It takes a string in. The string is only going to have one character. It's never going to start with any of this stuff. It's only going to have an upper or lowercase character and no things after it. Okay, so my claim, let's see if we can do this right. Let's see, what is that producing? Oh, how interesting. They've done something interesting. Okay, so they accumulate the context for you as you scroll through. That's an interesting change. So in a method, when I'm scrolling through it, I can see exactly what it does. Build note, I don't care about. Note parser produces a parse result. Okay. I mean, somewhere I have to call .parse. Okay, so this, I want to return, I guess I want to return, let's see, this is the thing that builds the parser, right? Oh, it's the parse method. Okay, so the parser, well, I want to say return build note dot, no, sorry, I want to say note parser dot parse of input. Okay. That gets us going. Okay, so if I call note parser with a slice, I get back a note. Okay, so if I call note parser with note string in ... like that, I believe. Okay, and this stuff can all go away. We'll hide it for a minute and make sure this all works. Okay. Cannot convert expression to return type note. Oh yeah, okay. Let the result equal that, and then we're gonna have to do things. Switch result. One case is failure, position and message. Another case is success. Let value and remaining. Okay. We'll just print for now. Message. Okay. And let's return note. Well, for now, let's return note C in key with octave 4. We'll just return middle C. Okay. And we're not handling the error case yet, so I don't mind doing something a little weird. This one, we are returning it. We got the value. Let's just return value. And C. Okay. Return value. Both things return. What's this one? Can I convert string subsequence to array slice of character? Okay. That's doing with this array slice of. I don't know. I'm going to try string here. It may mess up on me. I don't know. We'll see. Cannot convert slice of string to a slice of this stuff. Parse in my string. What's the matter? Cannot convert value of slice of string to expected argument type. Array slice of character. Who expects character? Somebody's. Okay. Is that better? No. No, exactly. Well, that's a string. Okay. Maybe that would be better. Switch for string is again a collection of characters. So array of string is characters. Okay, well maybe this should be character then after all. No. Can I convert array string element, i.e. character, to array slice? Is that the slice? Okay, and we don't care about remaining, yeah. Okay, built. Feeling slightly lost. Okay, well, the good news is it all works. All right, so I think basically yesterday we had finished writing this part. Today we've added build note that says, give me the pieces, I'll work out the octave modifiers and produce the note for you. Okay, so we've successfully converted this to what it was. Now, let's make sure that still runs. And I think, well, we'll get rid of the warning. Whoops. Okay, so we convert note to use new style parser. Now, okay, let's see our parse and code thing. So this thing doesn't change from that. And I think, again, we've taken a shortcut here. I put mechanism in for note handling, and we do test it a little here. We check the bass notes. Okay. I really should check these. Oh, here's the no. Okay. We're checking those. We're checking these. We're checking octaves. Okay. Let's add one that covers everything. Test notes with accidentals and octaves. This is kind of one of these confirming tests that I expect to just pass already. ABC parser dot note. Let's do double sharp B dot tick tick down up. Down up should be down 1. Okay, so we expect that to be note B double sharp. The net octave is 4, minus 1 is 3, minus 1 is 2, plus 1 is 3. So net octave is 3. And I expect this to just pass. Okay. All right. So I think what that means to me is our note parser is fine. And I'm going to change the name to just be note. We got note and notes, so let's be more specific. Note. This is notes. Okay. Okay. Let's see. Next step. Well, I think we want to lean on this parser some more. So I would like this thing to handle a list of notes and return the right thing. Okay, so I'm going to make another parser. And I don't know, this thing also, like I don't need to build the parser every time. Let's make that a known thing. Let's define note parser is well, it's a function. It's this. I think. Expected type. Declarations must be separated by too much. Okay. So it's a function that goes from characters to parse results. Okay, and now we need an initializer. Init. Okay, and init has to define note parser. This stuff is all kind of like static, except for this line. Oops, note parser.parse. So I'm trying to pull out everything above that. Here, I want to make a function out of it. Let's just do that. And it's going to be a static function because I'm just going to call it during initialization. Okay. Don't need that. All right. Static function. Whoops. let's call it make note parser. Okay. And it doesn't take anything, and it produces a function, which is this array slice character to parse result note. Okay. All right. And we're going to let that, oh dear, match. Let me look at my last project. Open recent. Basic. I think the initialization we did a different way. I don't know better or worse. We did this stuff. Yeah. And then make expression. Let's go to make statements. Make expression parser probably. And then where's match defined? Private function. Right, because we're doing this in the defer, we can do that. Okay, I guess I'm going to do the same thing. It's no longer static. Make note parser does this thing. This thing is implicitly not null because in the end we will call note parser equals make note parser. Okay, and that should be happier. Yep. We don't want this line. So we're just trying to build the parser itself. I'm going to pull these methods up. They're sort of the build helper kind of things. Okay. All right, to make sense of the parser, you're going to need to know those. All right, call make note parser. We build all that. Now, in is that not quite right? Where'd that window go? Make sure my type is, oh, it's on the back of this. Okay. Yeah, well, this bind may be a way to go too. It definitely helps make things easier to work with. So this, we just say bind our input type and our output type, and that. So I guess we'll adopt that. It'll require us to change our parser just a touch, but or our result type just a touch. Okay, so we're going to do this bind. It gives us a parser. Its parse function we can bind. Okay, and this is character to note. Okay, so this is sort of a simplified type. The bind simplifies the type, so I just say it's a character to note parser, and it's still not happy. Has no member parse. Well, note parser. Oh, we didn't return it. Okay, something's not quite lined up on the type front. Cannot convert this to Okay, let's simplify this one to make note. Let's just go ahead and do the bind here as well. So it's bind character note. Okay, and then in the end we'll return bind of character to note parser dot parse. Okay, I think that will be okay there. This is redundant here now. Okay, so we've got note parser. It's assigned. We called the make on it and built the whole thing up. And then in here, we do note parser. Let's say dot parse of that. Okay, and this is no longer needed. Okay, let's make sure that all hangs together. Okay, I realize it may be going by a little faster than you want to follow. Let's see if I can make this a little better. I don't think we need that stuff anymore either. Okay, so let's take it from the top and just kind of walk through because it's a pattern we'll use. All right, so we're saying there's going to be a note parser, which is one of these parser combinator parsers, and it's going to be a parse function that goes from character to note. It's not created directly here. It's not created in the main body of the init, so it could be null, and we have to account for that. And we're saying, I promise by the time you finish initializing, it won't be null. We do that with defer that says, do this after you've done all the real initialization, and I will let you call local functions and stuff like that, so we don't have to do the static stuff. That lets us have access to these methods. Okay, so our make note parser says, okay, build up these individual accidental parsers, the letter parsers, the octave parsers, and run, at runtime, run them through this build note function that will produce a note. And that whole thing, note parser, is a parser. A parser has a parse function, and so we can pass that parse function to bind, which tells us the type. Let's look at the type here. The type is bind, okay, whereas this thing, the type is horrible, okay, and the bind lets us kind of strip that all out, and from anybody calling note parser itself, they just know it's really a character to note. They don't care about all this complexity inside, okay, which is good from like a type checking point of view. It just simplifies the type checking. Otherwise, my whole giant parser turns into one huge, thousands of character long explanation of what the type is. We don't need that. Okay, now we have a parser notes that produces the notes type, which is a sequence of notes. It does its job today by breaking up the string into individual characters, which really have to be A, B, C, D, E, F, G, upper or lower, but still, okay, and calling note on it, which is a parser. And note says, give me a string, but really it's a one character string now, even though the parser knows how to handle it more. If it's coming from notes, it's only a one character string. Okay, we proved that it works over here with all these occidentals and octaves and all that. So I think we're good. That the note parser is okay. Now, how we're handling errors, I think that's probably that's a little awkward yet. I really want this error to just bubble out to the callers. And one way to do that is to make the callers deal with the parse results, and maybe that's okay. I don't know. We'll see. Okay, and that that covers us for notes. All right, now I'm going to go to the documentation because. All right, let's back to notes, pitch. Okay, so we handle G comma A comma all the way up to D prime that they show here. Yeah, more is available. Nobody likes to write that many bar lines above the staff. Okay, lower octaves are reachable with commas and apostrophes. You can mix and match. K or V can do it. We'll get to that later. English uses C through B. Yes, okay. Accidentals, we do those. And we have not dealt with note lengths yet. Okay. But we do deal with a sequence of notes, kind of. So here, A3B, well, the 3 deals with the rhythms, okay? But if you just had the notes like CD or if it was ABCD, we can handle that more or less. We don't know about spaces yet, so we don't handle that part right. But our notes thing kind of handles it. We have complexity coming in. I don't know. Notes is interesting because I need something that the analysis I want doesn't care about rhythms. So I need something that strips out the rhythm off the note, but I may need those rhythms at some point. So we're going to have to devise a scheme for that. But I will need something that lets me filter out all the rhythms and just give me the pure notes. Okay. Now I'm thinking maybe notes should be a parser as well. And let's just follow the pattern now, and then we can, let's just follow the pattern. Even we could do it a slower way, but I'm just going to write the parser in here. Okay, so a sequence of notes is really it's a note parser followed by it's one or more notes. Okay. I guess it's let's say it's one or more notes, or how do I want to do this? I need to deal with spaces. That spaces are a real thing. Yeah, I think it's either notes or it's match space. It can be one of those. And the whole thing, expected pattern. Oh, I got to let something equal. Let notes parser equal. Well, if I write it like this, that helps a little. It's one or more notes or one or more strings, and all this is repeated. Maybe it's one or more notes separated by one or more strings. That's probably the more accurate thing. Okay, and we have an operator for that. Ampersand says notes separated by one or more strings. Okay. If there are none, that's okay. You just have one. Otherwise that. And I don't think I care. Okay, I'm doing two things. That's probably not good. Let me do one thing. Okay, so the first thing I want to do is I want to make sure I can handle a string of notes. Now I'm willing to be generalized that I can handle a string of notes with accidentals and octaves. That's fine. If I do this, I'm handling one or more accidentals and octaves. I could believe it's 0 or more, but I think if I have 0, I don't really have a notes. I think that's true. We may find that we may decide there's a test for that and we can get rid of it. I think maybe it is 0 or more. in our input file. I guess I should look at that. All right, down at the bottom somewhere there's examples. Section 13, I think. Yeah, okay. So ABC file starts with ABC, %ABC. It's got a bunch of lines, and eventually you get to an X that says this is the start of a song. Here's its title. And after the key is defined, you get a bunch of notes. All this is notes. And we're going to have to deal with bar lines at some point. But the CD, BAG, those are notes. And I should be able to handle a string of those. But if I had nothing here, like these 3 lines were missing, I don't know. Do I have an empty song at that point? If you ask me for the notes, I certainly should tell you it's empty. Okay, so I don't know if notes are required. I kind of feel like I've seen ABCs without notes in them. Oh, what is this? Okay, there's all kinds of stuff. I mean, this is a really complicated format, all in all. Okay, I don't know what we're reading here. Italian or something? It's on Questy. Okay. Boy. Yeah, it's hard to know. Okay, I'm going to say you got to have some notes. Let's just assume. Somebody else can deal with the other case. Okay, so if this were the note parser and you called return notes with note parser if you call notes parser.parse with input, okay. Notes constructor is an array of note. This produces an array of note. The input is, we got to do a little playing around with it. It's got to be converted to a slice to conform to our parser. Array note string in ... Let's just call this input. Input of string. Okay. And this stuff is gone. Okay. So I'm bind character input, bind character out to expected argument type note. Yes, this is no, is that right? Bind character note input to, oh yeah, it's a parse result. Okay. Let result equal this. Okay, and then switch result of dot failure, let position, let message, and really it's the same. We'll adjust, but it's going to be kind of the same. Failure message, failed this, failed that. Let's return notes with an empty array. Okay. If success, we got a value back. Bind character note target. And we're going to return notes of the value. Okay. Switch must be exhaustive. And case. Print and return empty, return stuff. Okay. We did not handle any errors before, so now we're kind of clunking our way through them. But my point is, this should just work, barring the case of an empty thing. We might have an issue. No, it's okay. All right, and let's clean up this much. Well, I don't know. I should just check in. Okay, switch notes parser to new parser style. Okay. Now, I'm going to make the same kind of argument for notes as we did for note parser. So let's make one. Notes parser is bind character note. Notes. Okay. And we're going to do a make note parser. Notes parser equal make notes parser. And I don't know. I think I'm going to run into some conflicting things here. Part of it is like these notes, we got the bar lines, all this stuff. Really, I want to parse this file, so I'm not. The notes object is really the trim down. It's like a projection. It says, take all the information that you're going to parse from that string of notes. It'll include length, it'll include repeats and bar lines and all this stuff. Take those and strip them down to just the notes. So I guess I'm admitting at some point this notes parser is probably supposed to do a lot more and have a lot less to do with notes. We probably need a different type going on. We do need the notes type. It's useful for the analysis we're doing for Parsons code, but it's not quite where we're going. Okay, so notes. Now we got to make notes parser. Notes parser bind character to notes. Okay, and that is this. And we're going to return notes parser dot bind. Bind character to. Actually, I might not even need to say it. Can I just say bind notes parser dot parse? Will it infer it for me? Yes. No. Character notes to return type bind. Character array of notes. Oh yeah, right. This parser is going to have to do something. Okay. Notes parser dot parse. Yeah, we need to do the semantics here. We get an array. Okay, we get an array of note. That's the same argument we want here, so let's just do that here. That corresponds to this. Okay, we just need to return value. All right, so the notes parser produces notes given a bunch of matching strings, basically, lists of characters. Okay. We set up make notes parser. Now let's just call notes parser dot parse on the input. I think we're there. Hope I didn't leave anything out. No. Okay. Make notes parser be a standalone parser. I guess we'll say it that way. Now, all right. There's something funny. What's funny is right now notes, we're not calling it anymore here, right? Because we just call note parser, that thing up there, and we don't call this function. So if we find who's calling it, I think it's just tests. Yeah. Now that there's something to be said for that. But I think what there is to be said, I think this belongs in our test now. Because we're trying to really testing the note parser, and this function is now no longer needed. Okay, so let's take this and move it over. All right, so I'm gonna notes parse correctly. Well, let's just deal with note for a moment. I guess let's take note. Array note string note. Okay, let's. Yeah, I'm gonna simplify this. Let's make this. We'll just let it create a parser. Parser equals abc parser dot note parser. Okay. Let note parser equal that. Now note parser dot parse blah 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 is. Well, that doesn't sound right to me. Okay, if notes parser is abc.note parser, let's go see that thing. That's a bound parser. I should be able to call note parser.parse like I do here. Well, I do it implicitly here, like I did before, I guess. Note parser. Okay, optional type bind character note. Okay, let's do this. Okay, now I'm saying it, I promise it'll be there. Okay, so note parser.parse is what we were doing before with this abc parser.note. This is really just our note function now. Okay. Let's run this test to make sure it's happy with that. Okay, so I'm going to simplify all these. Is it this one? No. This one? Yes. Replace ABC parser nothing dot with nothing. Can't do that one because that's notes, but these should all be okay. Okay, and now note is no longer needed in here. Okay, and notes, make notes parser. Yeah, this is kind of the top level parse. Like this is the right now this is our highest level parse. You pass in the input, it deals with all the effects of that, I guess you'd say. Okay, and then build note, I'm going to move that up where it's used, which is on our make note parser. Okay. Make notes parser. Interesting. Okay. Now, okay. I think we're due for a break. Let's take a break. We're going to come back, and I think we're ready to do the next phase of this, which is really like find the tune, and we need to we basically need to get the notes and start digging up the rhythms and the whatever's significant in these things. Maybe the key is more important. It's like if you want to do the whole file, like for the analysis we have, it's misleading if you have, okay, key of D has F sharp and C sharp, and so if you were to have a file with key of D and something that went from C natural to C, well, the C is really C sharp. That should be a change, but we wouldn't register it the way we are now. We don't know about the key. Okay. And I don't know whether to, I think I want to build up the key structure a bit. I mean, there is a key. It knows something that we need to know. We need to be able to take a note like this, an A. Like when we're creating the note, we need to know what key we're in to put the right note. Because the A is just an A, but the C should be marked C sharp. And the way we are now, we just mark it as C in key, but we don't know what the key is. And the default key is no sharps, no flats, so we just think it's a regular old C. Okay, I think that'll give us something good to work on. All right, so let's take a about 3-minute break. We'll come back and introduce keys to our notes. And once we've got keys in place, at least to some level, I think we've kind of done as far into the file reading. Well, we need to read the key. Okay. But I think we've done as much as we need to do a proper parsons code and know the true notes being mentioned. Okay, we don't handle braces and less thans and bar lines and all that. We'll get there. All right, see you in about 3 minutes. Welcome back. All right, let's see what's involved in keys. It's, I don't want to say it's a mess, but it's a lot bigger than it sounds like it ought to be. Okay, K is key. We'll jump us there. Okay, so key is specified with A through G, followed by sharp or B for sharp or flat. Notice that's not the same as the underscores and greater arrows that we've been using. I don't know why they didn't pick the same thing consistently. Okay, but you can say A through G, sharp or flat. So here's C sharp, F sharp, and so on. Okay. There's a mode. Okay, so if you're not a music person, you may have heard of major and minor, but there really are 7 classical modes. There are other ones that get used too, but these get you started. Ionian, Aeolian, Mixolydian, Dorian, Phrygian. Actually, they come in the order Ionian, Dorian, Phrygian, Lydian, Mixolydian, Aeolian, Locrian. Okay. But anyway, you can specify the modes, and they have some number of sharps or flats. The sharps and flats that get used come in a specific order, and you're allowed to modify your mode. So you could specify D Phrygian, but add in a sharp F. Okay, D Phrygian is here. Okay, is normally two flats, which is B flat, E flat, and we're adding an F sharp. So most music I play does not have B flat, E flat, F sharp. You know, that's a it's a klezmer mode or Arabic. You can modify these things with particular notes. You can even just say, I'm going to be explicit, and I'm going to just tell you I want a B flat, an E flat, and an F sharp. Okay. And then there's yet more. Highland pipes, that's the HP, usually have C sharp, F sharp, and the scales that go with it. So D major, A mixolydian, E Dorian, B minor. Okay, those are all legitimate scales with that, or legitimate modes for that scale. Okay, but normally they don't bother notating them even. So HP says use this scale with the two sharps, but don't put a key signature. Just do that. Okay, but if you say HP lower P, we'll go ahead and put them in. Okay. Yeah, and change the way the beams go down. So cool. All right, so by default we set into there. You can add class specifiers to the K with or without a key signature. So you can say clef equals bass. There's a whole bunch there. First occurrence of K finishes the tune header. Everything else is the tune body. Okay, so in the example we saw, it said K colon G, and it went into a bunch of notes, and that's what they're saying is that's what's going to happen there, the tune body. All right, so we can take. Let's start with the simple form. It's a key, and it's got a tonic note, and a mode, and accidentals. Okay, now, this parsing is pretty, like, they look at the first three letters of the mode name, and I guess you could even spell it. You could call it Mixodorian, and it really only looks at the mix and says it's Mixolydian. Okay. Now, one way would be, well, like maybe we should start with some major keys. Okay, so let's do that. Let's assume you're going to say K colon G or D or B flat. And we want to get the right number of sharps and flats. And that we could almost do it with explicit as well. That would be another way to shortcut it. You tell me the key name, and I tell you, and the accidentals you want. Trying to think what's the right map. In a way, this compressed is okay. And I think you can put a space before the mode. Yeah, D Phrygian or together. Okay. Wow. Like where to start. All right. I think we're going to say there's a K colon line. It's going to have a note name. Let's not do the sharps and flats at first. Let's just do the ones in the middle here. And if you give the note name, it knows which sharps and flats to use. Now, I don't know if this is... there's something about this. Where did I see this? The case of the letter. Yeah, the case of the letter is used to determine which line the accidental is placed on. So let me go back to my example here. Okay. Notice this sharp. There's one sharp. It's an F sharp, and that top line is an F. There's another F, also an octave lower, on the bottom space. This one here. And the third note is actually an F because it's key of G with one sharp. It's F sharp. But you had a choice, like when you drew this F, where you're going to draw it, up here, down here. And there's kind of a defined pattern, like F, C, G, D, B, and it bounces around a certain way. What they're saying is the case of that letter is used as extra information to tell you where the accidental gets placed. Golly. Now, you don't have to put the octave, just the case gives you that. All right, so okay, we don't have octave modifiers. All right, so D major equals C. That's the high. Oh, they're saying D major with a natural C. Well, that's not really D major anymore. It's D mixolydian. D major with a natural C really is the key of G because there's only one sharp. Okay. So the information we need to know the key, right? We got to know, I guess, for this form, we need the tonic and the optional mode and the optional accidentals. Okay, so let's just start with K colon and then the note. And then we're going to do something to tell us what sharps and stuff there are. And I think the information we need is we need to know, well, the question we need to answer is, if I give you a note, F, and I say it's in key, and the key is G, you should be able to tell me, oh, your note is really an F sharp. It's kind of an implied F sharp. And you don't necessarily have to say the accidental. It's implied by the key signature. It's kind of a scope thing. Okay, so if I knew D, I know it's two particular sharps, and I don't have to worry about the case of the letter because I'm not going to do that yet. Okay, so I want to parse a key line, at least pieces of it. And let's start with a simple one. Okay. That's letter followed by accidental, and we're just going to do letter. Okay. So let's deal with it from a parsing perspective first. Okay, so I'm going to say this is a key parser. Okay. And the tests. They're going to get ugly. Not ugly, they're going to get big. Okay, so this is kind of sort of what we're doing. All right, test key. Test single letter key. Okay. We're going to take the parser. We're going to say what? Key for K colon G. And then we're going to assert, well, this is key is that. We're going to assert that key, and this is where it's less clear to me. what is it equal to? Maybe I should think in terms of the explicit notes. So the reason I'm struggling is this thing that I want to get every F, but I just want you to tell me a plain old F in octave 5. All right, let's say this is key of this stuff. Well, its name is G. Is that the name? Do we know? I don't know if that's the name or that's the bass note. Okay. Do I really like these names? Don't mean anything to anybody from a domain perspective. Maybe it's a name and a mode. I just don't know if I should be talking about notes at this point because I'm kind of representing all the Fs. But maybe I am. Maybe this is the key that corresponds to note G natural octave. See, the octave doesn't matter. I'll just say 4, which is kind of the middle. Yeah, I don't know. It's like, do I need a sub note kind of thing? Keynote? Like, would that be the right thing? G natural. Maybe so. But these other ones have their octaves. Maybe the octave doesn't matter. I don't know. This is why writing the tests is hard. I think maybe this is key of G, octave 4, but we don't really look at the octave too much. Octave 4, and then G has a note F sharp. Octave 5 is really where it gets marked. Okay. And what I want to come in with all right, so how's this looking? Parse out a key name. Come back and say this is a key of G. Its default sharps and flats are F sharp 5. That's the uppercase F. Okay, cannot find key in scope. Okay, I think that's reasonable. This octave bugs me a little. Okay, doesn't compile. All right, because the parser and the key. I think it may be that we want to define a new kind of note that ignores the octave, but let's start with this and see where we go. Okay, so let's create a class here. Class key. Um, it needs to know. Well, it probably is a struct. Struct key. It needs to know the key. The what do we call it? The bass note. The tonic. Tonic is probably a good name. Tonic is a note, and the accidentals is an array of note. Because they come in order, so that's probably the right thing there. Okay. This, I think I can just do it like this. Tonic and accidentals. That, I don't need to mess with the constructor just yet. I don't know if I get an equals for free. Conform to equatable. Almost free. Okay. And I don't have a parser function key. Okay. Test over here. Okay. Parser.swift. Okay, I got the test and the parser. All right, I need a key function. It does this, it returns a key. Okay, let's move this. I'll just put it here for now. We'll move it eventually. Okay. So I think we want to do just the same as this one. We want to call key parser. Maybe that's the same as we did with note. ABC parser.key. Okay, we're going to call gotta do this thing again. If we get everything aligned with them, they won't be as common. Okay, key parser.parse, and then we need a switch. Failure, failed, position message, return key. And let's just return note C natural for no sharps or flats. Okay. I can hide that for a bit. Okay. Okay. If you don't have a key defined properly, let's just return key of C. And then otherwise, we'll just return the value, which should be a key. We need a key parser. Let's put one up here. Okay. character and key. I wonder, can I? Yeah, okay. I guess I'm wondering if I can make a type alias for this. Type alias cbind equals bind character result. Can I do this? Interesting. Okay. I'll keep it for a minute and see what we think. All right. I know I'm getting distracted, aren't I? Make key parser. Okay. And make key parser. Well, I think we can say C bind of key. We need to match K, and then we ignore the result because we don't really care, and match colon, and again, we don't really care about the result of that. We know we're in the key line though, and we need a letter. Match, it's a range. Well, it's really this. Match one of A through G. Oh, so we don't need match. We got one of. Okay. One of A through G. Okay, so we would have key colon G. All right. And then let's call build key with the result. Okay, and we will return a bind, cbind of key with key parser dot parse, and we got to define build key to make this work. Function build key. It needs to know the letter, which one of, I think, will give us a character. Tonic of character produces a key. Okay. And let's just return junk for now. Okay, I think that will return that. Okay. What's the deal up here? Self-used in method key parser bind key exclamation. And I'm going to use my abbreviation. Okay, this should fail. Okay, C natural 4 with no accidentals is not equal to G natural 4 with one accidental. All right, that is progress. Okay, now these keys, let's deal with this mapping problem. So I'm just going to cover F through B flat. Sorry, F through B. Okay. Um, well, what can I do here? I don't want to make things harder for myself. All right, I'm going to define some accidentals. Okay, so let's start at the bottom. Let's say flat sharp sharps flats 0. That should be a list of notes. I don't know. Those notes are their own things. Let's do that too. Okay. The type of this is note. Okay. Key of C is that. Key of G is F sharp. Can I do that? F sharp is note F sharp 5. Okay, I think I'm getting there. Okay, let's just do a couple. We got key of G, so we just need F sharp. Okay, sharps 1 equals F sharp 5. Ay, ay, ay. Okay, let's have a function key map, and it produces well, somebody wants to ask the question, given a key name, what are its accidentals? That's a good question. Okay, which can become a map from key from note it's a map from note to array of notes. Okay, and it's gonna involve all this stuff, and then in the end it's gonna return well, in our case we got C natural 4 goes to empty array, and G natural 4 goes to sharps flats 1, sharps 1. Okay, I'm just going to do these two for now. Key map produces note, note, note. Note does not conform to hashable. Oh, this is becoming harder than I want. Let's set this aside. I guess let's dump it. Okay. I'm saying there should be a function accidentals for the key is a note and it returns an array of note. Okay. If key equals C, return empty list. And I think I can even do this. Switch key case C, return nothing. Case G, return note F sharp 5. Default, let's return nothing for now. Okay. Value of type string cannot match values of type string goes to key. I don't know why it's not giving me the key file code. Just key dot tonic. No. Note dot note name. Key's note name is C. Return. I just don't remember. Key is a note. Value of type string to key has no member note name. Key is. Sorry, let's rebuild. Cannot find make notes parser. What? Value of type string to key. I'm messed up here. ABC parser has no member key. Okay. Something's going wrong sooner than that, though. Notes parser equals make notes parser. I must have parens off some or braces off. Externals for key. Yes, I do. Okay. Make key parser. Build key. Where's build key? And this is our function. Accidentals for tonic. That's gone. Cannot convert character to note. Tonic is supposed to be note tonic natural, oh gosh, natural 4. Okay. Accidentals that note tonic. Make a string out of that for now. Okay, where are we going here? We got build key. Cannot convert character to argument type note. Tonic value type character to tonic note. Accidentals for key is a note. I think we just want the note name. Let's just do this for now. Get it green and then work on it. Cannot convert. This can be string of tonic. Okay. I think we have all the pieces now. We have a key function. Okay. Key parser. Key of input string. What's the problem here? ABC parser has no member key. Okay, I think it's just not caught up. Here we go. All right. So key parser calls key parser. Matches K colon A through G. Calls build key. Returns us a key. Okay, let's see if this works. I believe it should. All right. Parse simple key names to produce a key. Okay. Well, okay. I definitely want to extend this and clean it up. Whether I should keep going down this path. Okay, I'm gonna keep simplifying character. Move this down to string key. Get the callers. Take that string out. Note. Oh, he needs the string. Okay, so there's multiple dimensions we should do. Okay, let's make key. We're kind of doing that now, finally. Okay, so we got parse one letter key name. Okay, we make key. We're in the process, I guess. One piece of that. Did I just edit the wrong one? No. Okay. One piece of that is, does it understand all the keys? Okay. The answer is no. It only knows how to build these two. All right. This thing, I mean, this should just be a map somewhere. We need to go from, I think it's from a string. You give me a string, I will give you the accidentals. Okay, so let's change this to a map. And it's probably, we probably have to build it. Okay, so this is build accidentals for, and accidentals for is going to be a field. is a map from string to note. What are you saying? Well, I guess that should be a colon. Okay, string to note. And then down here, should be complaining about accidentals for. It'll get there eventually. Okay, this is build accidentals for. And we need to call it in the constructor. Well, let's make it make. Make accidentals. Okay, now here, build key. Okay, now I can do all that stuff I wanted to do before. Annoying, but maybe I can make it work. All right. We still need that lookup function. Okay, this is accidentals for. I should have kept the function declaration. Accidentals for, and it takes a string, takes a character, tonic of character, and it produces an array of note. Okay, and it's going to call, I'm going to rename it again, key accidentals of tonic. Okay, and key accidentals is this. Maybe it's even key to accidentals. Okay, I'll get there. Accidentals for is key to accidentals for tonic. Okay, tonic is a character. We'll make it into a string. One place. Okay, make accidentals for. Let's say let sharps equals. And it's going to be an array of sharps. And it's going to be, let's do this. It's going to be F, C, G, D, A, E. F sharp, C sharp, G sharp, D sharp, A sharp, E sharp, B sharp, and B. Okay, should be 7 notes. 1, 2, 3, 4, 5, 6, 7, because you can have 7 sharps. Okay, so now I'm going to make those into note. $0 sharp and 5. That's not really right. I may have to put it here too. Ugh. Golly. All right, let's leave it 5 for now and get this thing built and then worry about it. Okay, so my sharps, F, C, G, D, A, E, B. Okay, now I need my map. Okay, which is this, and it's going to be C goes to nothing, and G goes to sharp sub 0, which is F sharp. Okay, F sharp 5, and then if it's nothing, key to accidentals of string of tonic, else let's key to accidentals of C, bang, we're going to know that's there. It's all clunky, I agree. I can hear you complaining on my behalf. Okay, now how's this? Okay, make accidentals. We figure out the sharps and we return a subset of them. And this gives us the accidentals array. Problem. Remove key. Okay. Let's do a build. Accidentals 4. I change that name to key to accidentals. Is make that. Okay. Should be no change. Okay. Oh yeah. Wow. Okay. Let's add some tests. Let's check this in. We create a structure key to accidental, populate it, and use it in the parser. Okay. Yikes. There's a lot going on already. Okay, make accidentals. We build up, based on the sharps, we build the notes for them, which is not really accurate, but there we go. And we handle 2 keys. And okay, accidentals 4 looks it up and build key builds it by looking it up. I could almost inline that, but I won't. Okay. I want to handle the remaining simple keys. F, C, G, D, B, A, and so on. Okay. Well, I really want to handle the sharp keys first. Okay. Now, let's put a test in for these things. This is let me duplicate it. I have stuff for parameterized tests that I sort of created it, dabbled a little, and dropped. Maybe it's time to build that thing up again too. I don't know. These projects keep growing, but okay. I want to test single letter keys. Okay. And then for each one, let's call this check. Single letter key. I don't really care that it's not going to throw. Okay. Check single letter key. Well, G should be F sharp. These are sharp keys. Okay. Single letter sharp key G F. How about check sharp key G F? Really? You can't fit that? Okay. And this then takes a string, tonic of string, and the accidentals of array of string. Okay. Now, the key is really K colon tonic. The note should be tonic. Natural 4, that's fine. Accidentals note. This note should be, I'm saying G should have F sharp. Let's take the accidentals. Let sharp equal accidentals dot map each one to a note with that. Note $0 sharp 5. Okay, so I'm taking all those sharp names, turning them into notes, and then that should be the same as, I'll call it expected. Actually, I should probably call this one expected. This one accidentals. Expected accidentals. Okay. Cannot check sharp key and scope. Okay. This should be the same. I've more or less extracted a method and generalized it a little bit. Tonic expected map to the notes. Okay, and assert equals. Yeah, okay, but should pass. Good. Okay, so parameterized test. Now let's check the next key. Okay, D sharp. Key of D should have F and C sharp. This should fail because our table isn't big enough. Okay, one failure. D is not equal to D with F sharp, C sharp. Okay, came back with nothing. Good. And that was this else clause says just default to C if we don't know what we're doing. Okay. Now I've got a list of sharps. Okay. I want to say well, can I do this? Can I say sharp keys is G, D, And you notice these patterns repeat. The music is full of this. G, D, A, E, B. Okay, is that G, D, A, E, B or the 5 sharp keys? Okay. And let's see. I don't know if this map. It's like I want to build it up. All right. Well, these correspond in order in the sense that this takes the first one, this takes the first 2, this takes the first 3, first 4, first 5. Okay, so if I said sharp keys dot, what's the iterator that tells you the index as well as the key? Enumerated is enumerated sequence. No, it's not enumerated. What is that thing? So what's enumerated sequence? Maybe it is enumerated. Pairs index. Yes, that's right. Okay. Dot map. Each one of those turns into a list of stuff. Okay. I want to take. Oh. Okay. The N is probably 0 based. This is N and note in this. Okay. I want to say take first. I don't know what I can build maps from. Okay, let's see if we can figure that out. I mean, this all should be very elegant in the end, right? Map. What do I do with my link? Swift doc. Array dictionary. Init. Group by. A sequence of key value pairs. Okay, that is all right. The key is note, and the pair is sharps dot take. Oh, come on, keep. Dot. Oh. There's drop, right? Drop while, drop last. Well, I don't want to do drop last. I thought we got to keep first in here. That's the Swift UI list. Array.prefix gives me a slice, so I can turn it back into an array. Oh, that is really ugly. Array has drop first, drop last. Why not take first, take last? Yeah, I wish it had take first. Okay, yeah, I can do the subscript. That's right. Sharp sub 0 dot dot n dot 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 n. Okay, so I'm keeping the 0th through the 0th items. I think that'll be okay. And let's return well, let's return this for now. Is that going to be legit? Cannot convert string to subsequence to string to note. String. Cannot convert string array of note dot subsequence, aka string array slice, to return type string to note. Oh, yeah, I need to do a dictionary of this. Okay. Let key signatures equal that and return dictionary of key signatures. Is that going to work? I thought we decided it. Dictionary. Unique keys with values. Zip digit words to 1 to 5. Yes. Oh, I got to say unique keys with values. Oh. Okay. So I think we can pass the tests for all our sharp keys if we put those in. Let's do that. G, D, A, E, B. F, C, G, G, D, G, D, A. Okay. And the check is the key name is always one step higher than the last sharp. So A sharp goes to B, D sharp goes to E, G sharp goes to A, C sharp goes to D, F sharp goes to G. Okay, I believe these tests will all pass. Okay. And I think we can even get C in here. I think we can make it work. It doesn't work now, I don't think. found nil. Yeah, okay, because it doesn't map anything. Okay, so unrepresented optional. Oh, this one, yeah. Okay, because we didn't handle it. I think if I do C and I map, I don't know if I can say 0 to n minus 1. If that would be empty. I don't know if I want to get, yeah, okay, I can't do that. All right, let's take a different way. Okay, this goes back to 0 to 1. And take C out. Okay. Let C key is of notes is empty. Okay. So key signatures, let's make this sharp key signatures. Okay. And I need to get this in the list. Okay, so I think, can I concat sequences? Let all key signatures equals C key dot concat dot append contents of sharp key signatures. Okay. So I'm putting the C yeah, I really should do this way. String and a note, array of notes, is C goes to nothing. Okay, now all key signatures is C key signature append sharp. I guess I still have to do this. What an immutable value. Okay, we'll start with C key signature, append the other signatures. Let's do all these key signatures. Okay. So my claim is I'm making the C sharp signature. I'm making these signatures. All that maps that. All key signatures plus sharp key signatures. All key signatures. And I hope everything passes. I believe everything should pass. C is covered now. Okay, let's take this out. That stub. Okay, and we handle keys G through B. the backwards, well, the pattern going the other way. See, we had F, it's like it's two behind. F, C, so the key of G starts with F sharp, the key of D adds C sharp, the key of A adds G sharp, and so on. Skips forward to. The flats kind of go the other way. F picks up B flat adds E flat adds A flat. They're all like one ahead. Okay, so the last flat tells you the next key. What is going to be? Now this one, the notes almost have to be the same. Okay, let's deal with the flats. I think we can, well, we only have to do one flat key right now because F is the only single name flat key. Well, let's do F key signature equals, it's F goes to the note B flat 5. Okay. And can I say dot append F key signature? No, I have to do this again. Okay. All key signatures dot append F. Okay. Oh, I should put the test in as well. Sharp. Okay. Well, do I need to check flat key? Let's extract method on this. We'll call it check key signature, like that. And let's add accidental is an accidental, and the check sharp key, the accidental is sharp. Okay. And if we, let's make a check flat key. With the accidental flat. And then I think up here we can make a check flat key. Single letter flat keys. The only one is F, which has B flat. Okay, and if I've done this all right, that should just work. A little backwards in my TDD, but okay. Add support for flat keys, just F for now. Okay. And let's mark this here. Switch note to a P combo parser. We did that behind here. Make key. Well, we made the class. And parse key start with simple, with how about one letter keys. And then we want to do the rest of the parsing next time. Parse remaining keys. Maybe it's add accidentals. Okay, so F sharp, those keys, the first two and the last 5, 6. All right. Well, we've made a fair bit of progress today on the parser and the keys. I think we'll get the simple key signatures, like the major keys, done next time. Cover major keys, and with that, I think we'll be able to make a more complicated. We'll be able to take the key signature and a string of notes and do our analysis, and that should actually work. We probably can put in a little bit of. We might be able to put in a little parsing that just says ignore the characters we don't understand, and I'm fine with that. So we'll look about doing that next time. Then we can feed in real files and get something out. The stuff is more complicated than you might think. I mean, you can actually put key signatures in the middle of a song and stuff like that. So it's the full complexity is a ways away from our reach, but we can get closer. And with that, I think we'll call it a day today. And I hope I see you tomorrow. It's 1 to 3:30 p.m. Eastern Time or 6 to 8:30 p.m. UTC. Have a good evening. Take care. Bye-bye.